Hi everyone. Let's look at a couple examples about the relationship between the graph of a function and its derivative. Now for this first example we have this cubic function, and let's just play around with this graph and see, okay, if we go along, just watching the red ball that goes along with it, we see, okay, what is happening to the derivative of this function as we move it along the curve. Now, let's first look at the tangent line as we move along the graph of this function. If you notice, okay, that the line is going up and down at various points. So if you see at first, when we're going from left to right, the graph is going up for the line, then it becomes horizontal for a bit, then it goes down, becomes horizontal again, and then it goes up again. So how does that relate to the derivative of the function? Well, the slope of the tangent line is the derivative of the function for that value of x. So like if you see here, at this point right here, the graph is going downwards. So you see that this slope of the tangent line would be negative. But then if you move just a little bit more to the left, the more you go over, it gets closer and closer until eventually it would be close to a horizontal line. And then as the graph is increasing, the slope of the tangent line will become more and more positive. Now let's look at the graph of the derivative function. So this would be in red would be the graph of the derivative function. Now let's start again this little thing and seeing, okay, you see, as I was saying, the tangent line is going upwards, so the slope is positive, so the graph of the derivative is above the x-axis for these values. But then as we go a little bit more and more, you see what happens here when, once again, the graph of the derivative becomes almost horizontal. Well, you see that that's where the derivative crosses the x-axis, because when the derivative is 0, that's when the graph of the function has a horizontal tangent line. And then as it's go along even more, we see that the slope of the tangent line would be negative, so the graph of the derivative would be below the x-axis. And then again it's going down, so the graph would be of the derivative would be below the x-axis. Then once again, when it reaches this point where it goes horizontal, this is where the graph of the derivative would cross the x-axis, because again, the derivative of the function would be 0 because the slope of that tangent line when it's horizontal would be 0. And then it goes back above the x-axis, because the slope of the tangent line is positive, so that means the derivative is positive, so the graph would be, the derivative would be above the x-axis. Now looking at another example, let's say if we were talking about the absolute value function, f of x equals to the absolute value of x. Now again, if we just go along, we see, okay, we have this v-shaped graph, but what happens to the derivative for this one? Now, if we were to also show the tangent line, let's see, that's what it would be in purple. If you notice, the tangent line would be pretty much the same, but then it jumps to going from downwards so the slope is negative, and then it goes to positive. At this corner point it jumps. So if you were to actually graph the derivative of this function, this is what it would look like in black. That the derivative would be -1 for all of this left side, for the graph of the function to the left of the y-axis, and then it jumps up to being +1 to the right of the y-axis. So because the derivative as we approach from the left hand side would be -1, but as we approach from the right hand side would be +1, at 0 the function is not differentiable because it does jump at this value of x equals to 0. So hopefully that gives you a little insight about the relationship between the graph of a function and its derivative.